Assalamu alaikum students. Let's start the second part of waves chapter. Okay, the previous MCQs are present in the first video. You should watch that one. Okay, let's start 24. A string of length 100 cm. Here is string and length 100 cm vibrate in 4 loops. If both ends of string are clamped, what does it mean? It means that this will make stationary waves. Okay, then the wavelength of the wave is, let's find the wavelength. Okay, look here, it's the shortcut formula for finding wavelengths of waves. Okay, 2 multiply length is 100 cm. Okay, and loops is 4. N here means that loops are 4. So 2 multiply 100 is equal to 200, and when we divide 200 with 4, you will get what? 50. Okay, the lambda will be 50. Now let me give you the visual concept. What does this MCQ mean? It means that here are the 4 loops. Okay, and the length is equal to 100 cm. And we also know that in terms of lambda, what is the length? Look, this one is lambda by 2. Okay, I have told you that in case of stationary waves, take lambda by 2. This one is lambda by 2, this one is lambda by 2, and this one is lambda by 2. So here it will make 4 lambda by 2. Now the length is also equal to 4 lambda by 2. 1, 2, 3, 4, 4 lambda by 2. Now bring 2 here and 4 in division. You will get lambda is equal to 2L divided by 4. Okay, you have to find the lambda, so bring it on the other side of the equation. Now length is 100. 2 multiplied by 100 divided by 4, you will get 50 centimeter. Okay, so because the length is in centimeters, so you will get 50 centimeter. So, and this one is the formula for the MCQ. Here option B is correct. 25. In a resonance tube, the second harmonic takes place at 75 centimeter. The wavelength of the wave is. Now look, the resonance tube means that this is the closed organ pipe. Okay, the one end will be closed here like this. So they are saying that second harmonic, look, this one is second harmonic. Okay, if it was from here to here like this, okay, if it was from here to here, it would be first harmonic, and this one is now second harmonic. Now look, length is 75 centimeter, and in case of closed organ pipe, I told you that take lambda by 4, and from here to here it is lambda by 4 and lambda by 4. Now the length will be 1, 2, 3 lambda by 4. Okay, here you have to find the lambda. Now bring this 4 here and 3 in place of division. You will get lambda is equal to 4L divided by 3. Okay, now 4 multiplied by 75, you will get and divided by 3. Now 3 ones are 3 and 3 25s are 75. So you will get 100 centimeter answer. The lambda will be 100 centimeter. Now look at the previous MCQ, this one. Okay, this formula is valid for stationary waves. Okay, and here in this case it is resonance tube, which means that this is closed organ pipe. Now you have to do this one. Okay, lambda is equal to 3, lambda is equal to 4L divided by 3. You have to do this one, so you will get lambda is equal to 100 centimeter. Here option B is correct. Okay, the short formula for this one is, for closed organ pipe, the short formula is lambda n is equal to 4L divided by 2n minus 1. Okay, this is the short formula. In place of n, put second 2. Okay, put 2, and here also put 2. You will get lambda 2 is equal to 4, and place of length put 75. Okay, 75, 2 2s are 4 minus 1 3. So you will get 100 centimeter. Okay, this one is a formula for closed organ pipe. The speed of wave in the string of guitar is 500 meter per second. Now look, string of guitar means that it will make stationary waves. Okay, because the guitar string are clamped from both sides. Okay, so it will make stationary waves. If the length of a string is 0.5 meter, then the fundamental frequency of sound waves is. Now look at here, what is fundamental frequency? When there is one loop, then their frequency is called fundamental frequency. Okay, here we know that the length is equal to lambda by 2. Okay, and the length is also equal to what? Length is also equal to 0.5 meter. So in this case, f is equal to v divided by lambda. Now you put the value of lambda, so it will be like lambda is equal to 2L. Okay, lambda is equal to 2L, this one. So v divided by 2L. Now look, this is the fundamental frequency, okay, of stationary waves. We know that length is 0.5 meter. Now put here 0.5. When you multiply these two, you will get one answer. Okay, now the fundamental frequency will be 500 hertz. Okay, 500 hertz. Here option A is correct. Okay, fundamental frequency is 500 hertz. Now 27. The wavelength of sound heard by stationary listener Look, the listener is stationary, okay, due to the relative motion of sound source. Now the sound source is in motion, but we don't know in what direction, okay. It is only given that the sound source is in motion, but the direction is not given. Now look at here. This is the sounding source, S sounding source of sound, okay, and the sound waves travel here, like, and this is heard by a stationary listener, okay. This is heard by stationary listener. Look, the V, this is observer, okay. V is equal to 0. Velocity of the observer is equal to 0. Now look at here. We know that here the relative motion of sounding source, which means that the direction is not given. So there is two possibilities. The sound may be in that direction, okay. The motion of source may be in that direction, or the motion of source may be in the opposite direction, okay. Look here. V is the speed of sound, and the Vs is the speed of source, okay. Vs is the speed of source. Now look at here. Take this one reference, okay. Take the speed of sound as reference, okay. Now if the speed of sound and the speed of the source is in same direction, then you have to subtract this one, okay. You have to subtract this Vs from V, okay, or you have to take negative, okay. Take this one negative or subtract it from the speed of sound. Now look, if the speed of source is in opposite direction to this one, okay, if it is in opposite direction, then add this one, okay. Add the speed of source with the speed of sound, okay, like this. If the direction is opposite, then do addition or take this one as positive. Now look at here. Look, in MCQ we have to find the wavelength of sound, okay, wavelength of sound. Now look at here. We know that lambda is equal to V divided by F, okay. This is the wavelength of sound, wavelength of sound. Now look, there is two possibilities. The source is either moving in that direction, or it is moving either in that direction. Now put V plus minus Vs, okay, V plus minus Vs divided by F, then you will get the lambda, okay. The equation of lambda will be like this: V plus minus the source speed divided by frequency of sounding waves. Now look, we know that this lambda is the wavelength of sound source, okay, the wavelength of sound. But if the sound source was stationary, if this one was stationary, then the lambda would remain same, okay. If this one was stationary, then lambda would remain same as this one. But now it is in motion, so the lambda is changing like this, okay. Look here, the option D is correct, okay. Lambda is equal to V plus minus Vs sounding source divided by frequency. Now the 28. The frequency of sound heard by stationary listener. The listener is stationary due to the relative motion of sounding source. Now look, here it is not given that in which direction the sound source is moving. Now let's find the frequency of sound, okay. Now look at here, for Doppler effect, in order to find the new frequency for Doppler effect, this one is the basic equation. You should memorize this one equation, okay. Look, this O represent observer and this S represent the sounding source, okay. Just memorize this one equation, then Doppler effect will be very easy, okay. Now look at the condition. Here the observer is stationary, so here velocity is 0. The sounding source is in motion. This is the velocity of sounding source, and here velocity of the source, this is the velocity of sound, and the velocity of the source is equal to Vs. Now there is two possibilities. The source is either moving in that direction, or it is either moving in opposite direction. In case of same direction, subtract this one, and in case of opposite direction, add this one. Now look at here. Put in place of V0 0, okay, because the listener is stationary. In place of V0, put 0, and here Vs, so it will remain like this, okay. V plus minus Vs, okay. So the new frequency will be V divided by V plus minus Vs, because there is two possibility. It is either moving in that direction or in that. So V plus minus Vs. Look, option A is correct here, okay. Next one. The change in the frequency of sound heard by the stationary listener is because of the change in. Now let's find this one. Here the listener is stationary, the observer is stationary, and the sounding source is in motion, okay. The sounding source is in motion. Look at here, the condition is like this, that the sound source is moving with velocity Vs and the observer is stationary here. Look, the change in frequency occur because of the motion, okay. Change in frequency occur because of the motion of either source or the listener. Here the listener is stationary, so it means that the source must be in motion, due to which the change occur. Now look, this is the condition. So here we know that lambda is equal to v divided by f. Okay, look, this lambda is the wavelength of speed of sound. Okay, the wavelength of sound. Okay, this lambda is the wavelength of sound. Now look, v is the wavelength of speed, v is the velocity of speed. We know that the sounding source is moving with some velocity either in that direction or in opposite direction, so you will put v is equal to plus minus vs, okay, divided by frequency. This is the lambda. Okay, this is the wavelength of the sounding source, the wavelength of sound. Okay, now look at here, we know that the change in frequency is equal to v divided by lambda. This is the frequency of the sound. Okay, here the sound frequency is remain as same. Okay, now look, here lambda, put here the value of lambda. Okay, so you will get lambda is equal to, frequency is equal to v divided by v plus minus vs divided by f. Now bring this f here, okay, in numerator side. So you will get v, new frequency is equal to v divided by v plus minus vs multiplied by frequency. Now look, this is the change in frequency. Okay, in MCQ they have given that what is the cause of this change in frequency. So look at here, going to here, this one, the change in the frequency is because of the lambda, the change in the wavelength. Okay, now look at the MCQ, the change in the frequency of sound heard by the stationary listener is because of the change in wavelength of sound. Look, change in the wavelength of sound. Now you don't have to do all these mathematics. Okay, just memorize this one, that conclusion. What is conclusion? When the source is moving and the listener is stationary. Okay, when the source is moving and the listener is stationary, then in that case the change in frequency is due to the change in wavelength of sound. Okay, memorize this one. Okay, that when the source is moving and the listener is stationary, then the change in frequency is due to the change in wavelength of sound. Look, change in the wavelength of sound. Now 30, the frequency of sound heard by the listener due to the relative motion of the listener. Now look, motion, the listener is in motion. Okay, and the frequency of sound, now we have to find the frequency, and the change in frequency is due to the motion of the listener, not the sound source. So in that case the sound will be stationary, the source will be stationary. Now look at here, this is the sounding source and the speed of sound is v, and the source speed is equal to 0 because it is stationary, and this is the listener, observer, its speed is equal to v naught. Now look at here, we don't know that it is either moving in the opposite direction or it is moving in the same direction to the speed of sound. Okay, it is either moving in opposite direction to the speed of sound or moving with same direction with the speed of sound. Now if it is in opposite direction, then do addition, and if it is in same direction, then do subtraction. Okay, look at here, the basic formula of Doppler effect. Okay, the change in frequency. Now the sounding source, velocity of sounding source is equal to 0, so put here 0, you will get v only. Okay, and the velocity is equal to v naught. Now frequency is equal to f, v plus minus v naught, and here you will put 0, so you will get only v. Now this is the equation when the source is stationary and the listener is moving. Now look at the options. Look here, option C is correct. Okay, option C is correct in that case. Now look at the 31. The change in frequency of sound due to the relative motion of listener is because of. Now here the sound source is stationary and the listener is moving. Now what will be the effect? What will be the reason of the change in frequency? Okay. Now let's find the cause in change in frequency. Look here, the sounding source is stationary, so its velocity is 0, and this is the velocity of sound, and here the observer is moving with v naught. Okay, moving, its velocity is v naught, length of sound. Okay, this is the wavelength of sound, which is equal to v divided by f. Now look at here, the speed of sound is same. Okay, it is as same because the sound source is stationary. Then it will be, look, the lambda will be remain as same. Okay, because the source is not moving, the speed will be the same as v. Now look at here, new frequency will be v divided by lambda. Okay, v divided by lambda. What is this one v? This one v is the velocity of sound relative to the listener. Okay, relative to the listener. Now look at here, we know that velocity of sound relative to a listener is v plus minus v naught because the listener is moving with v naught. Okay, so you have to put v plus minus v naught. Okay, So this is the speed of sound relative to the listener. Speed of sound relative to the listener is changing. Okay, it is V plus minus V naught. Now look at here, put this value here. Okay, so you will get frequency is equal to V plus minus V naught. And look at here, the lambda is remain as same, V divided by F. So it will be like this. Now bring this frequency here, okay, in numerator. So you will get new frequency is equal to V plus minus V naught divided by V frequency, okay, original frequency. Now in MCQ, the required is that what is the reason in change in frequency when the source is stationary. Now look at the reason. Look, the reason is the relative speed of sound, the speed of sound relative to the listener. Okay, the change in frequency is due to the speed of sound relative to the listener, and here the wavelength remain as same. So the change is due to the speed of sound relative to the listener. Now look at the options. Look, here is the option A is correct, change in relative speed of sound. Okay, now in conclusion, when source is stationary and the listener is moving. Okay, here source was stationary and the listener was moving. When the source is stationary and listener is moving, then the change in frequency is due to the change in relative speed of sound. Now you should memorize this one. Okay, memorize this one. When the source is stationary and the listener is moving, then the change in frequency is due to the change in relative speed of sound. And in this case, the wavelength remains same. Okay, wavelength remains same. In this case, only the relative speed of sound changes and the wavelength remains same. So here option A is correct. Look at the next one, 32. A sounding source approaches a stationary listener with a half of speed of sound. If V is the speed of sound, then the frequency of sound heard by the listener. Now look at here, from this MCQ, we got that approach mean that the sound source is moving. Okay, a sounding source approach a stationary listener. It means that the sound source is moving, and it also means that the sound source is moving towards the listener. Okay, the source is moving towards the listener. Now look at this. Now look at here, the condition is like this is the source of sound and the sound is moving with speed V, and look, the stationary listener, its velocity is equal to 0. And look at here, the speed of source is half of the speed of sound. Okay, the speed of source, the source is moving with half of the velocity of sound. Okay, here the speed of sound is V, the speed of sound, and the speed of source is equal to V divided by 2. Now look at here, the basic formula of Doppler effect. Okay, memorize this one. Now look, V naught is equal to 0 because the listener is stationary. Okay, and here in this MCQ, approach mean that the source is in the direction of speed of sound. Okay, so you have to put V minus Vs. Okay, same direction, take negative. Okay, take minus. Now look, Vs is equal to V divided by 2. So V divided by 2. Now look here, when you take the LCM of both, you will get V divided by 2. Okay, V minus V divided by 2 is equal to V divided by 2. Now bring this 2 here, you will get 2V divided by V. Now cancel these V, so you will get F is equal to new frequency will be 2 times of the original frequency. Okay, look, when the speed of source is half of the speed of sound, then the new frequency will be 2 times of the original frequency. Look, just memorize this one equation. Okay, and from MCQ, here approaches mean that the speed of source and speed of sound is in same direction. Then put here negative, so you will get the F is equal to 2F. Okay, look here, option A is correct. Look at the next one. Beats produced by sounding two frequency source together that differ in frequency by. Now look at here, the difference of frequency must be less than 10. Okay, the difference of frequency must be less than 10. So in that case, the beat will be observed by human ear. Okay, next one, this one, the uncommon characteristic in sound waves and transverse wave. Now look, reflection is occur in both waves, diffraction is also occur in both waves, dispersion is also occur in both waves. Okay, look, sound is a longitudinal waves. Okay, so these three phenomena occur in longitudinal as well as the transverse wave. Here the polarization is uncommon. Okay, polarization only occur in transverse wave. Okay, polarization only occur in transverse wave. In longitudinal waves, polarization does not occur. So here option C is correct. Doppler effect is applicable to sound as well as the light waves. Okay, so here option C is correct. Look at the next one. The speed of sound wave is independent of pressure. Okay, the pressure do not affect the speed of sound. Look at the next one. Which of the following does not transfer energy through the particle of the medium? So here option C, standing and stationary waves does not transfer the energy. Okay, and these both waves, sound waves and the water waves, are progressive waves. Okay, so they transfer the energy, and does not transfer, so this one is the standing or stationary waves. So this one was the last MCQ of chapter 8 waves. If you like the video, then share it with your friends and subscribe my channel. And if you have any problem in any MCQ, okay, then write in the comment section. Allah Hafiz.